Everyone, my name is Fathimah and today I'll be presenting the comparison between two main electric traction power delivery system, the overhead catenary system and the third rail system. So these both are used to supply electric to the rings, but the way they work are different in terms of their structure and application. So to give you the overview of their difference, you can look at the picture in this slide. So the top one where you can see the wires, and so on, they are the components of overhead catenary system. They also take place on top of the rail system. So the third rail system is the one that you can see on the bottom. So it involves the railing lah, because of the name you can relate that it involves railing components. Next.
How do electric trains get their energy while running? Electric trains obtain their energy from overhead electrical cables. They use a device called a pantograph, which can be raised and lowered to draw electricity from these wires. The flexible pantograph ensures that the train remains connected to the power source while in motion, providing a constant supply of energy to keep the train moving.
So trains are powered by two ways, either an overhead rail or something called the third rail, which is what we're going to be talking about right now. If you've ever looked at a train track closely, then you'll notice that there's the tracks that the train actually sits on. Then there's an extra piece of metal running down the side of the train track. That, my friend, is called the third rail, and that is highly electrified. But the way that it works is that the train wheels actually go onto the train track. On the train there's something called a conductor shoe, which is this thing right here. This conductor shoe sits onto the third rail and powers the train.
So, in order to simplify what the video has said in terms of power collection and position of power, so basically the video says that the overhead catenary system supplies power through wires above the train. So the train use pantograph, basically the ones that is like arm looking you see on top of the train, it stays connected with the wire above. It stays in contact with the wire above. So that's how they supply the power to the train. And that is the position of the supply, which is above the train. And on the other hand, the third rail system use rail mounted beside the track. So the train draws current using contact shoes that slides along this train. So that's how they draw current and supply power to the train. So the position is on the train rack. So let's see in terms of voltage type. So as you can see, the overhead catenary system carries high voltage, while the third rail system use low DC voltage, typically around 550 volts. Let's take a look in terms of distance. So we know that the overhead catenary system is actually very suitable for long or high speed, long distance or for high speed use train, because they deliver more power over long distances. So you also see that actually long distance train has the wires and the pantograph. Well, usually, for example, like the one that use the rail system are usually for short distance. You can see the application on which train they are being used in the further slide.
Okay, now we will compare the electrification system that is being used in Malaysian traction system. So in Malaysia, there are two mainly that system that being used in Malaysia, which is 750 volt DC system and 25 kV AC system. So both of these systems have voltage level of 750 volt DC and 25 kV AC. So where does it supply to? Okay, 750 volt DC system, it supplies to both OCS and TRS. Meanwhile, the 25 kV AC system only supply to OCS. Okay, why? Because when we talk about 25 kV AC system, we can easily look at the amount, how big of the voltage is, right? So when we think about TRS is third rail system, right? It's based on the ground, which there are people nearby, there are possibilities of people walking. So it's very dangerous for 25 kV system to be implemented to TRS, because as we learned in the last semester in high voltage class, right? So we know that high voltage can jump through the air even without contact. So it will create arc flash, which is very dangerous to the people nearby. Alright, so that's why the 25 kV system only supply to the OCS. So next we will look at the application. So 750 volt DC system is used in urban transit, while 25 kV AC system used in intercity trains. Why? Because okay, in urban transit like LRT Kelana Jaya, we have like 31 stations, right? So it is very nearer to each other. And why it use 750 volt DC? Okay, when the distance is shorter, we need to quick acceleration and deceleration because we don't have time to wait, right? So this DC system only need a little volt, and it requires a huge amount of current to create the same power. Remember, like our equation, the equation of P equal to IV, when the V is small, the I is high. When more current create more losses. So that's why 750 volt DC system needs to the distances is shorter to each other, and the other one is 25 kV AC system. It uses intercity trains like KTMB. KTMB is like the one that I know is one from the Tanjung Malim to the I think Bandaraya. So it's very far apart, right? So why uses 25 kV AC system? This is because it's placed with the efficiency, which is the next slide. It plays with the efficiency, where 25 kV system we have a big amount of voltage, and we need only small amount of current because small amount of current means small losses. So it means it can get the same power with only a little current, and that's why it's very efficient for intercity trains. Moving on to the application of 750 volt system. Before I said that it uses in urban transit, right? So why? Because urban area is full of people, full of buildings, so we need a compact system. Okay, compact system to supply the power to the train. So this system will not have poles, no need wires, so it's very compact for the crowded area. Also, because of safety reason, which is urban area is when urban area is full of people, we need a very small system voltage. We need small voltage, and 750 volt system is very suitable for urban area. Like I said before, the application is very related with the efficiency, so that's why 750 volt DC system have lower efficiency for long distances, while 25 kV system is very good for long distances. The efficiency is higher. So let's talk about the cost. Okay, the cost. Why 750 volt DC system has higher cost? Okay, remember our equation, which is P equal to IV. So to create the same amount of power, and 750 volt DC system is very small amount of volt, right? So we need more current. So more current mean more losses. More losses mean more cost. It's just that. And 35 kV system have lower cost because P equal to IV, V big, I small, cost small, right? That's it. And okay, last one is substation spacing. So the 750 volt DC system is closely spaced to each other, and 25 kV system is widely spaced. Okay, what is the function of substation? Okay, substation will receive power from the grid, right? It receives a very big amount of power voltage from the grid. It will step it down, and for DC system it will change. It will transform the AC system to DC system and supply to the train. Okay, why it's closely spaced? Because it's closely spaced is because, remember, 750 volt DC is small, so the substation need to be close to each other to continuously supply the power to the train, right? What if, imagine if the substation is far distance from each other, right? If the distance is far from each other, then when the substation send the voltage to the train, and because of the small amount and the big distance, when the voltage received by the train, it will be very small and the train might not likely to generate power. Okay, the next one and the last one is 25 kVA system. Is the substation is widely spaced because 25 kVA is very big, right? So the amount of losses is very low. That's why it's can widely space. Okay, that's all.
Hi everyone, my name is Aisyah. Let's take a quick ride through how electric traction system are actually used right here in Malaysia and how they impact our environment and safety. Use cases in Malaysia. In Malaysia, we use two main types of electric traction system: the overhead catenary system (OCS) and the third rail system. First up, we have the overhead catenary system. This system uses overhead wires and pantograph to power the trains. You will find it on KTM commuters, which runs intercity services, ERL, which connects the city to KL Airport, and the MRT Putrajaya and Kajang lines. Why OCS? Because it supports high voltage 25 kV AC, making it perfect for long distance travel with fewer substation and lower power loss. Next, we have the third rail system. It's mainly used on the KL monorail and certain other LRT lines. The system uses a power rail beside the track and operates at 750 volt DC, which is better suited for shorter urban routes. So, the decision isn't random. Malaysia uses OCS for speed and distance, and the third rail for compact inner city system. Next, we have the third rail system. It's mainly used on the KL monorail and certain other LRT lines. The system uses a power rail beside the track and operates at 750 volt DC, which is better suited for shorter urban routes. So, the decision isn't random. Malaysia uses OCS for speed and distance, and the third rail for compact inner city system. Now, let's move on to environmental considerations. One thing both systems have in common: they are way more eco-friendly than diesel-based transport. Electric traction system produce no local emissions, lower noise pollution, and can even recycle energy using regenerative braking. And how efficient is that? This makes electric trains a big win for sustainable urban planning, especially in cities struggling with congestion and air quality. Now, let's talk about safety. OCS systems are generally safer for public areas because the wires are up high and out of reach, but they do require strict maintenance, especially in storm-prone areas, to prevent damage or hazards. The third rail system, on the other hand, is closer to the ground, which means it can pose an electrocution risk if not properly fenced off or protected. That's why it's typically used in controlled or elevated environments like the KL monorail. Also, for an infrastructure standpoint, DC systems need more substation due to voltage drop, which adds more potential failure points, while AC systems like OCS can space substations further apart, making them more efficient over long distance. In short, Malaysia's use of electric traction isn't just a smart from a transport perspective, it's also a step forward in safety and sustainability. And that brings us to the end of our journey through Malaysia's electric traction system, from voltage levels and components to real-world use cases and sustainability. We have seen how different systems serve different needs, with overhead catenary powering long-distance routes like KTM and MRT, and third rail keeping things moving in compact systems like the KL monorail. But more than just moving people, this system reflects our push towards safer, cleaner, and more efficient public transport. Thank you for watching, and we hope this presentation has been as electrifying as the system we explore. Terima kasih and stay charged.